Intro, Scorecard Showdown, US versus Russia versus China. A clean, big-picture comparison in 8 minutes. For decades, the skies have been a chessboard for global powers, and the kings of that board are the fifth-generation fighter jets. We're talking about the American F-22 Raptor, the Russian Su-57 Felon, and the Chinese J-20 Mighty Dragon. Forget the hype, forget the propaganda, and forget the forum arguments. Today we're taking a look at the real-world capabilities of these incredible machines, placing them side by side in a structured comparison. This isn't about which one looks coolest, or which one wins in a video game, it's about the technology, the doctrine, and the industrial base that puts these aircraft in the air and keeps them there. The format for today is simple and direct. We're going to break down each nation's air combat philosophy and capabilities one by one. After we've gone through each nation's roster, we'll bring it all together for the main event, a head-to-head scorecard across stealth, sensors, maneuverability, and combat readiness. The goal isn't to crown a universal winner, warfare is too complex, but to give you a clear data-driven framework for real-world matchups, so let's get started. Let's begin with the United States, a nation that has defined what a fifth-generation fighter is. The cornerstone of their philosophy is information dominance, achieved primarily through stealth and sensors. The F-22 Raptor and the F-35 Lightning II are the benchmarks. Stealth is about reducing signature from all aspects, including infrared and electronic emissions. It's hard and expensive, and the US has a head start. Stealth is not just defensive, it's an offensive enabler. It lets pilots see opponents before being seen. The second pillar is superior sensors and data fusion. The F-35 is often called a flying quarterback. Its distributed aperture system and advanced radar build a 360-degree picture. The fusion engine ingests data from sensors, friendly aircraft, satellites, and ground stations, then shows a single coherent battlespace picture. That networking is a massive force multiplier. An F-35 can detect a threat and pass targeting data to an F-15EX miles away, which then launches a missile from safety. This coordination relies on AWACS, satellite networks, aerial refueling tankers, and allied partners. It's an ecosystem built for networked warfare, proven in real combat. But there are costs. These jets are extremely expensive. An F-22's flyaway cost is staggering, and sustainment is where the real expense lies. Stealth coatings and complex systems need climate-controlled hangars and specialist crews. That maintenance reduces mission-ready rates. Numbers are another weakness for the F-22. Production ended in 2009 with only 187 built, leaving a small, precious fleet. The F-35 is produced in much larger numbers, but it was designed as a multi-role strike fighter, not a pure air-to-air brawler. The F-22 remains the king of air dominance in BVR fights. The F-35 is the ultimate sensor platform and network node. The US is also upgrading fourth-gen jets like the F-15EX with big radar and massive payload capacity. The US approach prioritizes BVR kill chains using stealth, sensors, and networking. But if that tech advantage is degraded by jamming, cyber attacks, or counter-stealth, it could force close-range fights, the challenge Russia and China are building toward. Now, we turn to Russia, a country with a long and storied history of designing incredibly potent fighter aircraft. Their design philosophy is markedly different from the American approach, where the US prioritizes stealth and information. Russia emphasizes extreme maneuverability, powerful engines, and long-range air-to-air missiles. They build aircraft meant to be physical gladiators in the sky, a legacy of the Cold War. The most visible feature is thrust vectoring. Russian jets like the Su-35 and Su-57 have movable engine nozzles. This lets them perform post-stall maneuvers like the Pugachev's Cobra, giving an edge in close dogfights. Complementing agility are powerful engines and long-range missiles. Russia developed missiles like the R-37M to target AWACS and tankers from far away. Doctrine, fire salvos from multiple platforms to overwhelm defenses. But there are trade-offs. The biggest is stealth. The Su-57 has some stealth shaping, but engine nacelles and construction seams make it less stealthy than US jets, more low observable than very low observable. Sensor fusion is another weakness, strong radars and IRST, but fusing into one intuitive picture lags behind, increasing pilot workload and slowing decisions. Production and logistics are concerns. The Su-57 program has faced delays and a slow ramp, with sanctions and economics limiting mass production and components, raising questions about effectiveness at scale. The standout is the Su-57, large, powerful, exceptionally agile with 3D vectoring, a multi-role fighter whose primary strength is air superiority. The real workhorse is the Su-35S Flanker E, a 4.5 Gen, brutally effective dogfighter with lethal nose pointing at close range. Russia optimizes to survive BVR and force a knife fight, while using long-reach missiles to attack the enemy's support network. And tankers, to create chaos and level the field. Overall, the most agile missile-focused of the three powers, but constrained by industrial, avionics and sensor fusion challenges. Their effectiveness ultimately hinges on whether they can produce enough aircraft, fix avionics, and close the information gap. Chapter 3. Finally we arrive at China, changing the strategic landscape faster than any other. China's approach is characterized by breathtakingly rapid modernization and production, a strong emphasis on electronic warfare, and a clear ambition to match and eventually surpass the United States. They learn from both American and Russian philosophies, picking elements from each while adding their own priorities. The most visible symbol is the Chengdu J-20 Mighty Dragon. From a design perspective, it clearly shows the influence of American stealth concepts, a long blended fuselage, diamond-shaped wings and canted tails, hallmarks of reduced frontal RCS. Like the US, China sees stealth as critical for surviving and winning modern air battles, investing enormous resources to master it. Alongside stealth, China places huge emphasis on electronic warfare, blinding and confusing enemy sensors with powerful jamming, spoofing communications, and protecting their own. Aircraft like the J-16D fly with J-20s to suppress air defenses and fighter radars, creating corridors for strike packages. This integrated EW approach is core strategy. China's undeniable strength is the speed and scale of production. While the US manages a small F-22 fleet and Russia slowly builds Su-57s, China is churning out J-20s, J-16s and J-10Cs at a rate alarming Western observers, iterating with improved engines and updated systems. Newer batches feature domestic WS-15 engines aimed at Super Cruise, though reliability and performance at scale are still being evaluated. The J-20's shape is optimized for stealth, but the quality of radar-absorbent materials and manufacturing tolerances is not public. Its side and rear signatures remain uncertain. Western analysts generally assess it as stealthier than the Su-57, but likely not yet on par with the F-22 or F-35, especially for all-aspect broadband stealth. It's very good, but perhaps not the benchmark. The J-20 is a large, long-range stealth fighter to penetrate sophisticated air defenses and establish air superiority. Its size implies large fuel fraction and spacious internal bays, ideal for Pacific distances, the centerpiece of China's modernization. Alongside it, the J-16, a heavy twin-seat strike fighter akin to the F-15E, with a potent EW J-16D variant, and the J-10C, a modern lightweight fighter with AESA and advanced missiles, form the mass backbone. Overall, China is the fastest improving and mass-producing power. In a regional conflict near home, they can leverage numbers plus dense layered ground-based radar and missile support, an A2AD strategy to raise costs for outside powers. Pragmatic and ambitious, they are closing the tech gap, learning fast, and using massive industry to challenge American air supremacy, the most significant long-term peer competitor. So, what's the final verdict in this clash of titans? As we've seen, each nation brings a unique philosophy and a distinct set of capabilities. It's not a simple case of one jet being better, it's a complex interplay of strengths and weaknesses that shifts with the scenario. The American F-22 and the F-35 rely on a system of systems, a networked web of stealth, sensors, and data to control engagements beyond visual range. It's a clinical, information-driven approach. Russia, with its Su-57 and the Su-35, bets on raw power and agility, using long-range missiles to disrupt the enemy's network, then winning the knife fight if one develops. China plays a numbers game with the J-20, leveraging industrial might and integrating stealth with powerful EW to build a formidable regional defense. Bottom line, US, most advanced and combat ready. Russia, most agile and missile focused. China, fastest improving and mass producing. Which factor matters most depends on the scenario. A one-on-one duel is not the same as 100 versus 100 under heavy jamming. The winner depends on pilots, the training, the logistics, the support assets, and the overarching strategy. Thanks for watching Scorecard Showdown. Like, subscribe, and tell us which matchup you want broken down next.